Hi everyone, welcome to Policy Engine training session for July 2025. My name is Wahid Ahmadi. Uh, Today, I'm gonna explain and present some content related to household simulation to Policy Engine, and I'm going to deep dive to a structural reform and parametric simulation and also parametric simulation related to household simulation. So from the household side. The next month, I will present a macro level simulation to you. So the other part of the policy engine. Um, for today, our objective is that I will explain with the coding and programming and all this stuff. First, create household simulation with proper entity relationship. Then I will explain about how we can run simulation and how we can calculate different variables and different layers of variables and how they are connected together, and about the variable dependencies, how we can see the calculation trees and different layers for the variable. Then how we can create and apply reforms, some complex reforms, some simple reforms, about comparing different scenarios. For example, building a kind of reform and then try to compare the result to baseline. Talking about a method called calculate data frame. If we have some multi-variable analysis, it's a useful method. And then I will show you an example about how we can calculate marginal tax rate through incremental changes, and a method again called axis. If you have a very parameter and analysis response, it's useful. I will explain to you. So let's start. I talked about the learning objective here, but I want to emphasize on that today we are actually learning about data structure and policy engine as well. And again, how we can design and implement some reforms, learning about them, learning about the variables, entities, parameter. So explain in details after presentation. Just feel free to ask any question. Before I start, I want to say the code that I'm showing to you is from PolicyEngine US. So you can see the first command of the introduction is from PolicyEngine US import simulation. So you can find a duality here between PolicyEngine US and PolicyEngine UK. So each part, every code that you are seeing here are applicable on the PolicyEngine UK as well. So the first command would be for if you are analyzing on the UK side is from PolicyEngine UK import simulation. So all of the Python code, you can walk through the documentation that we have. We have comprehensive documentation on everything about the coding and programming, about the variable, the code base that we have, and the law we translated to code. So I'm showing kind of US side analysis, but you can easily apply the UK side as well for yourself. Okay, for the first part, we want to start with creating a household situation. The core concept with starting an analysis with Policy Engine is that we want to understand the key components of our analysis. So first, we have entities like person, tax unit, SPM, family, household. We have different variables, can be inputs like employment income, or we can have a kind of variable after calculation, like the child tax curve, for example, or CTC values. We have some parameters like tax and benefits values and amounts. We have period, for example, different years we can apply. Um, about the repository that you can find all the codes and all the readmes and documentation. We have PolicyEngine US, and I said we have PolicyEngine UK as well. Similar thing, similar structure. We have PolicyEngine Core as well. And you can find the simulation Py package, the micro simulation Py package here. And if you want to understand about the variable parameter, you can go to the code base, PolicyEngine US and PolicyEngine UK, and see the structure, see the different layers, and understand how they are connected together. As you may know, we have a kind of web interface for PolicyEngine as well. So everything you can do here, you can do it as well online. And so you can enter some sample household and try to analyze on the web app as well. So basically, if you try to open this simulation, you'll go through a kind of analysis for the household side. So in one tab, I will show you later. In tab, you can extract the code. So we basically give you the direct code to the analysis that you simulated through the web app. And this is a ready-to-use Python code. So we will provide this content to you for each analysis that you try to simulate within the app. Okay, for this example, you can see a kind of situation that we are using later. That includes some people. So you can see different entities, different layers here. For the group of people, we have parent 1, parent 2, child 1, child 2. Okay, and we have ages and employment income. And you can see that, for example, in 2025, this is a kind of list of variables we want to assign in each year to that entity, to that person. Okay. You can see that, for example, for the employment income, we put some variables here for 2025 and also ages for 2025 for these people. And then we want to actually give the model the structure that we want to apply. We want to say that, okay, we have one in the families, we have one family with these members, okay? And again, we can have marital status and tax units, again, same structure, SPM units, household, same structure. But for the UK side, we don't have a state code here, CA that you're seeing here. This is what we have for the US side. Okay, when you have a situation, when you build a kind of example of household that you're having in your mind, part 2 is basically with that situation, we want to run a baseline for analyzing this household, okay? What we're doing here is that we are using the simulation command here and pass the situation that we built here. For which period? For 2025 as an example, and we want to extract and calculate some variables. For example, employment variable, we want to get we have a baseline without any reform, just calculate the employment income in this period. We can calculate tax-related variables here with the Python code, or benefits or net income. Just pass these variables name to the baseline underline C, but calculate. Next step is understanding the calculate return values. This is important that when you use the calculate method, you will return a numpy arrays with values for each entity. Okay. For example, for person level variables, we have array length of number of people. Okay, because this is a person level. Or if you have if you want to get the household level variables for that situation, you will have 1 in our case. You can print out some, for example, the arrays of employment income for the person level, and you can print out the shape. I will explain everything to you later. But I think it's good to have a kind of understanding about different built-in functions and methods and properties that we have. When you want to use a built-in function, you can pass the object that you have in parentheses into the function. So as an example, you can see that the max of array, sum of array, or length of array, you can pass them here and calculate if you have a built-in function. And if you have some methods like sum, like max, or like min, okay, you can pass the object dot method parentheses here, okay? And what is the difference between the method and properties? The properties are without parentheses, and you can just, for example, when you want to print out the shape, you may see in other places as well. You don't need parentheses here. You just can print out the arrays that shape or data type or so. About the shape, if you have some one-dimension array, the shape would be this one. And if you have 2D arrays, if you print out, for example, you'll see the rows and columns. And if you have higher dimensions, etc., you can expand it to the other dimension as well. So let's see an example here. For the household level variable, you can actually print out the shape, length, values. You can see that the different example of built-in function methods and properties here. And if you want to using dot sum, the dot sum is the method here. You can just call it like employment underline income variable that we have, dot sum, and you will get the sum. And this is an example of about the properties that you have, the object of properties. This is how you can call it. Here you can see some common arrays operations, for example, getting the total sum or getting an average, maximum, minimum. And when you're coding with PolicyEngine Python package, you can always print out the steps that you're taking, and it can actually help you with understanding what is the structure and have a kind of sense checking in each iteration that you have, as you can see here. Part 3 is understanding variable calculation flow. So it's important for us because we are open source, so we can track everything here. There is no black box. You can have a trace on each variable, each layer. The trace features show how PolicyEngine calculate variable step to step. So you can see the connections, interconnection between the variable, how we can calculate different variables. And how you can see that, okay, by changing one variable, what happened to the others. When you have a simulation like this, you passed your situation to the simulation, you have a kind of baseline. You want to see the trace and the tree of the variable. You can set it to true, dot trace equal true. And then what do you want to calculate? For an example here, CTC value, child tax credit. And for child tax credit, we want to see the layers, the variables that are participating in this calculation for this variable, okay? But we can set a max depth to 3. We don't want to deep dive in details and all of the variables that are connected to this. Just the max depth to 3 is enough for us. For an example here, you can see that what variables are connected. For example, in the CTC value, we are calculating CTC. which is divided to some calculations from CTC maximum with ARPA addition and CTC phase out. And you can track and have a kind of sense check about that. It's helpful to have an anatomy, to have an understanding about the anatomy of trace line as well. So what is that here? The component, the CTC in this line is the variable name. This is the year, and this is the branch. We usually set it at default. We can different branch as well. And also, we have the value of this variable. Okay, this is in the bracket. You can see the values. If you set the max depth to 4, you can see we have more components here, more layers, and more details here. About the trace output, you can see the indentation and also variable name, the calculation values that we have. For example, if you have arrays with 4 values, you will get the arrays of course, with 4 variables. You can see the time period that is involving in that, and also the max depth. You can set it to none as well. Okay, let's jump to part 4. Part 4 is creating and running some reforms. Okay, but first, let's have a discussion and understand about parameter type that we have. We have some some parameters that they have some single values. What I mean is that you can see some structure here and a variable that we have in our code base. It has a single value. Maybe we have some list parameter. For example, there is a parameter that you can pass a kind of list. Okay. For example, you can say that what are the program extension for the other program. So you can pass some names, some list names to that parameter as well. You may have some scale parameter. So for example, you can set a graduated scales with thresholds and rate as well. We can have some breakdown parameters. For example, you can pass some, I don't know, joint, couple, or everything for different type of the parameter. It has some breakdown within that. Okay, and you can pass. You can read the notes and pause the video to understand that, and also explore more. And you can code by yourself. Okay, about the accessing a scale parameter, we have, if you have a scale parameter, we have some thresholds, some rates, and some amounts. The example could be that, for example, for a program, for a benefit program, you may need to assign a threshold, an income threshold, to be eligible for that program. Or you could be an example to assign some rates. So if you are within a specific income threshold, you will be assigned some rates, okay, from the benefits or amounts. You can see that the thresholds in bracket 0 is the first threshold, and so on. Let's jump to the example here. How you can build a reform. Here you can see that there is a reform. We are passing a dictionary to a reform that for this parameter, we want to change the amount of this parameter to something else. Okay, and we are passing the country ID to US, so you can do it with UK and other examples. Or you can pass many items in that dictionary. So you can have a comprehensive reforms and again pass some changes, some other variables parameters with new values to the dictionary to the reform. When you build a reform here, and basically from before we have a kind of baseline as well. Okay, so as we did for the baseline, here we can do for the reform as well, the simulation, I mean. So we are passing the situation. The situation was here, the situation, the people that we built from the household side, okay? Sorry for scrolling, okay. We are passing situation, and also we can pass to the simulation a reform. So what happens if you are passing and giving a reform to the simulation? So basically with PolicyEngine, you can give some reforms to the simulation, and PolicyEngine code will calculate everything later of what you want to actually calculate and what analysis you have. What I mean is that when you pass the reform to the simulation, so you have named it to reformed underlying sim. With reform underlying sim, you can calculate the income tax in the period that you want, or CTC values, or household net income, and everything. And then you can print out the variables of the reforms. So you can see an example here. So this is a parametric reform. You just change the parameter here, okay? For different, for example, threshold rates or values for different years. And the dates here are, you're changing within this date the amount of this variable to this amount, okay? The advanced part is when you want to have a kind of a structure reform. So maybe you want to change the structure and underlying method of a tax or benefit program. Maybe you don't want to just change a parameter values. You want to completely change a reform here, have a kind of a structure reform. So within this example, you can kind of define a kind of class similar to what we are doing at PolicyEngine. So for different programs, we translate some regulations and law and some structures to some class and functions. And then we are building on top of what we have on PolicyEngine. So we are adding different programs and so on. Similar to that, you can define some classes here with functions. So you are passing some values type, float. This is just an example from salt cap calculation. You can read it more about this on a PolicyEngine research section. You can pass entity, label, unit of this variable, the documentation, the definition period is the year, for example. And then within this formula function, you can add your calculations and how you want to, for example, deal with this structural reform that you're proposing here. For example, the return is getting minimum from these two variables plus 1,000. And then when you have this class, you can have your reform class and pass the previous class to that. With self.update underline variable, you can actually update this variable. So in PolicyEngine, we build this CTC underline value, and you want to structurally change that, okay? With this command, you can change the structure of this variable. Okay, now you have a kind of a structural reform. Parametric and non-parametric, we know how to build them. For this step, you want to compare baseline and reform, okay? So by creating a data frame, comparison data, we are actually passing different variables to a data frame, and then we want to print it out, okay? So we have some metrics: federal income tax, child tax credit, household net income. They are just names. You have baseline. We called it previously income tax dot sum, CTC sum, household net income dot sum. And also we have some reformed income tax. We call them here later, here, before the search will change. And we count them as a reform, and then we want to print them out and also have a kind of comparison here. What is the percentage of changes from a baseline to a reform? We can also use calculate underlying framework method, and we can first, let's just explain about the different entities level and data structure that we have in PolicyEngine. We have, as we said, we have person level data, person level and layer data that we have, and it will go through, if we sum up some group of person, we'll go through tax unit, SPM unit, and household. Okay, just for an example, let's say we want to calculate these variables, okay, and name it variables to calculate, and we define the period for that, okay. The default behavior is automatic entity resolution. So when you don't specify a map2 parameter, I will show you the map2. What is map2? Parameter calculate underlying data frame automatically determine the appropriate entity level based on the longest entity needed to present all variables. So by default, it actually consider the longest entity needed to actually include all of the information in the longest way. Okay, by using calculate underlying data frame and pass it once to baseline underlying scene, and the second one is reform underlying scene, you can actually calculate these variables for two different scenarios, baseline and reform. And then when you print out the reform underlying DF and baseline underlying DF, you can compare these two scenarios. Like here. Here is the reform data frame, and here is the baseline data. Okay, maybe you don't want to print out from the person level, or you want to change it to, I don't know, the other entity level. You can use, for the calculation underlying data frame, you can use the map2 parameter here to person or tax unit or other entity. You can check it online and PolicyEngine documentation, what map2 options that you have. And then you can print out once again these variables, but map2 person. Okay, so maybe you want to map2 to household. Here again, you can actually print out the household level here. How map2 aggregation work? Okay, we started from person level variables. Okay, summed within the target entity. We have some person in one entity. We called it household. Same level variables as we kept as is. For example, household net income is already at household level, so no change. And then we have some intermediate level variables summed to the target level. As an example, is if there were multiple tax units, their income tax would be summed. Let's have an example here. The export.df is we are passing baseline.sim, underline sim to that. You are calculating this variable. Which entity level is household, the period reset. And then we can, we want to assign an identifier because we want to save it, okay? We want to save it, and then we can have a different scenarios for different, for different household ID. We can print out and have a CSV file or data frame for the baseline values. But we map to household level here. Okay, part 7 is about creating earnings variation charts. So one of the features that we have in PolicyEngine, we are providing some beautiful charts here to represent in your presentation and getting more insight to the analysis that you are doing with PolicyEngine. We have some, we have all of the charts, bar charts, line chart, and winner, loser, and distributional chart that we have in the web app. You can create some households here and toggle include earning variation in the reproduce in Python section. And here is an example. If you just go through the web app and see the example, you can actually extract the Python code here. The access method that I'm now want to present to you is that basically with the code that you extracted from PolicyEngine, you can see that, okay, you have a people level that, for example, your partner, your first dependent and your second dependent, and then you can pass it through the family entity, marital status entity, and again, similar to what we did. And then you want to, as an example here, you want to create a plot here, okay? And you want to set the x-axis and y-axis. And the axis is, for this one, is just an example. We want to create based on employment income from a minimum to maximum with a count. And here you can, for example, this is how we can set the axis here. Let me show you. Okay, this is how you can set some axis here. You need to pass name, count, how many data points variable that you want to between the space you want to be in. And the minimum and maximum. Yeah, you can pass many access names and variables, so you can make many plots, analyze different variables based on each other. Examples are, for example, you can create plots based on rent, mortgage interest, medical expenses, childcare expenses, and you only need to change names. And don't forget to adjust these variables if needed. Yeah, example here is that, again, same structure, passing a situation to the simulation. What is the situation with access here? The situation with access is what you extracted from web app, or easily you can write it by your own in Python notebook or Python environment. And then when you created a simulation, then you can pass it through access underline sim.calculate. For this one, for example, you can build a map plot for the employment. For the second one, you can plot household netting based on household, okay? See the map to option here. Then when you created different variables for the plots, for different variables number, the count that we explained here, you can pass them through a data frame. This is optional, okay? You can create with these variables vectors to the data frame here. and then print them out. Okay, maybe you want to pass some parallel access as well. For example, this is an example for you want to set different ages and also different income at the same time. This is doable with PolicyEngine as well. So it gives you many opportunity and flexibility to understand and calculate when you're building some baseline and reform. Then you are flexible to actually create many things, many stuff. For example, the bar chart, line chart, distribution analysis chart, and so on. And when we go through, we have the flexibility with the situation. You can change the situations here. You can pass, for example, a family with only 2 parents, there is no child here, and then you can add a child dynamically. Okay, so you have a situation here, and you want to add to this situation some number of children here. Okay, for age, for example, 9, 8, 7, etc. This is doable as well. So maybe you don't want to kind of hard code here children, and you want to dynamically generate them. You are able to do that, and then you can print out the CTC values based on different situation that you are building here. We can see an example. The household with 1 children, CTC is this amount, and so on. And when you want to visualize the data easily, you can just pass the variables. You can first add trace and go a scatter to get a scatter plot with that. And also you can set the depth here. And if you want to actually update the layout, it's easily, you can just set the tick format and everything, and you can use some templates. And when you pass the related variable, for example, CTC here, to the X and Y, the X has income range, okay, and Y is CTC range. And you can then plot this graph that you built and see what happened. Okay, for summary, just for takeaways, we explained that we have the hierarchy of entities structure, we have person to tax unit to household, and then we explained about the variables and the dependency between variables and how we can calculate the tree and connection of the interlayers between the variables. And you can build some reforms. You can modify parameter or add new calculation logic even. So we talked about parametric and non-parametric reforms. Then we talked about flexible methods for analysis within PolicyEngine and how we can simulate different classes. And also about the integration of the data frame method to PolicyEngine and how we can just easily, it can actually decrease your time of your analysis, and it can easily apply to your analysis as well. So looking ahead, for the next month, I will go through PolicyEngine economy-wide simulation. So everything that we had for this session was kind of household level analysis. I will walk through economy-wide simulation as well. And also we'll talk about public services analysis that we had. And we newly added these kind of features for public services analysis, PolicyEngine UK. Save the date for the next training session. And if you have any other or any question and discussion, feel free to ask.